Morning everyone. The 4,000 tonne threat of Chinese cranes. It's a bit of a catchy headline, it's not that scary. But I think where I'm going to go today provides a good follow-on from Hansi's great presentation, I guess demonstrating what Liebherr are doing to achieve that 200 metre hub height. And here we've got an insight into what some of the Chinese manufacturers are doing, I guess on the same scale with different types of cranes to try and get up around that 190, 200 metre plus hub height. So I guess we all know Chinese cranes are gaining momentum, there's no doubt about it. They're bigger, cheaper, improving rapidly, and we know that they're no longer easy to dismiss. Now, when I shared something on this recently on LinkedIn, I guess the response was almost as expected. And here's a few of the comments, for example. China will never make a crane like Germany, their build quality just isn't there. I'm worried how much testing and due diligence really happens before these machines turn up on site. And a big crawler like an LR 11,000 would destroy an all-terrain on a wind farm, for example. That comment comes from the States where they're traditionally tracking across paddocks as well. But I guess these types of comments, and especially the first two, in my role are actually largely irrelevant, and I don't mean to take away from the importance of safety and quality. But in my role as a lift engineer, essentially when the boss comes in and says, we now have a 4,000 tonne all-terrain, here's the manuals for it, here's the books, plan the lift, make it happen, that's what the job is. We work out if the crane can achieve the lift safely, and document how to do so to give it to the crane crew to go and execute that lift. Now, just not to skip over the safety and quality concerns, they're of course real, but I just put this up there because I think we're all seeing this trend. We're seeing the trend with cars. I dare say there's a BYD in the car park right now. Earth moving equipment, there's a number of Sony XCMG earth moving equipment getting around right now, and even wind turbines, as we've just seen. So I think there's no doubt that Chinese cranes are coming and consistently growing, and that they're definitely here to stay. It's more a matter of when, but not if, with these larger all-terrains. So with that in mind, let's make some assumptions for a moment with regards to the dream that I'm talking about of that these cranes are ready to go. And let's say we're a few years into the future, the quality is there, they're designed and certified to EN 13000, they meet all our plant design requirements in Australia. I was fortunate enough in November last year, thanks to Nationwide Machinery Group, the Zoomline dealer for Australia, to head over to Changsha in China and see the Zoomline factory for myself. Now, to be honest for myself, this was quite an eye-opening experience, having not been to any of the other Chinese factories before. And I feel like I wouldn't have felt like, if this was a Tesla factory, for example, I wouldn't have been surprised. Everything fully automated, clean, amazing production systems, and the response from a lot of the other people who had been to other factories with the other manufacturers were, this is what they're all doing, and that everyone is impressed when they see all of these different manufacturers. But for me, this was the first time that I laid eyes on a 4,000 tonne all-terrain crane. So the Zoomline crane, 96.3 metres of telescopic boom there. It's got 111 metres of attachments that then go on the end of that. And just for example, if you're talking like to use it in infrastructure, you could be doing 100 tonne at about 47 odd metres. If we're talking in wind, we're talking 230 tonne to that 190 metre hook height. Now, I mentioned Zoomline. I was lucky enough to go there, but they ain't the only one. We know the three Chinese manufacturers, the main players, being Zoomline, Sany, as well as XCMG. Here's Sany's version. They're all very on par with what they can achieve, and that's what we're going to have a look at today. Sany, 81 metres of boom, plus 106, and still about that 100 tonne at 50, 230 at 90, as well as the XCMG version. Now, when we look to compare these cranes, it doesn't make sense to compare it to European all-terrains. Shout out to Max's, who have the largest all-terrain in Australia, as well as Cube, who have the DMAG model. So we've got the Liebherr LTM 11200 there, 1200 tonne all-terrain, currently the largest manufactured by Liebherr, and DMAG also make an equivalent size crane. Now, these cranes are nowhere near the vicinity of what the 4,000 tonners can do, and rightfully so, understandably. When we're comparing to the 4,000 tonner, we're looking at these other cranes on the screen. We're looking towards the LR 11,000, the LR 11350, the LGs, and the big DMAG crawlers as well. That's the sort of vicinity that we're reaching with these large all-terrains. So I want to just show you basically what these cranes can do on paper, as it is impressive. So let's start off boom length. Okay, they've all got varying lengths of telescopic main boom and lattice boom attachment. Okay, but all getting up around that 200 metre hub height requirement. If we have a look at just some of the other standard stats, we're looking 16 by 16 outriggers on the Zoomline, with the XCMG and the Sany running 15 by 15. So comparatively, LG 1750, 12 by 12, LG 1800, 13 by 13. If we're going with Zoomline there, we're taking up an extra 3 metres in both directions of hard stand already. Counterweight up to 400 tonne, 340 and 350 on the other two there. And noticeably the XCMG is running a slightly smaller diameter windstroke with the 18 tonne line pull, but that's on par with, I guess, the LG 1750, for example. So, this is page 1 of 2 of a graph. This does not yet have the all-terrains on it. This is a graph of where the machines that we're comparing to sit. Now, Hansi, based on your presentation, I think I could give you a step up at the end here with the 11,000. But just for reference, we've got capacity at hook height. So if we look at the 150 metre hook height line, for example, it says no laser, so I won't be pointing. We can see that we've got the Liebherr LR 11350 along with one of the DMAG models at the top there. That blue aqua colour line in the middle there, I've included the Sany 1,000 tonne lattice boom truck mount machine that we just seen before. So we can see that actually gets a bit of an increase on the other cranes as well, hence why that's having an impact in the market. Then below that, we've got the 11,000 and the LG 1800 and LG 1750. Okay, about in the ballpark. Now, just out of interest, so what I'm going to do, my next slide is going to add the capacities of these all-terrains to this graph. So, quick show of hands. If I was to say they're going to be roughly below the trend of the other cranes, would anyone take a punt on that being the case? No one's willing? What about being within the band shown? Do we expect that they're going to likely sit within that range? Yeah? A few people think that's likely reasonable. And what about above the band? Do we expect they're going to sit well above that band? Yeah, quite a few heads nodding. So here it is. So what you'll see, Forgive me, I know the colour coding's a bit difficult to read, but essentially what I've shown is the 3 Chinese 4,000 tonne all-terrains, and they're all within relative ballpark of each other. So I won't bother in singling out which one, you can see from the colours, but essentially we see that once we get up around this 190 metre hub height or hook height, what I'm referring to here, we've got significant increase in capacity from these all-terrain machines. And seeing that on paper is quite impressive and eye-opening, and almost unfathomable to go, how does a telescopic machine, no superlift tray at the back, actually achieve that capacity? Very impressive that it is possible, and it's definitely being done within domestic China at the moment. So yeah, and that's the point. These are telescopic boom cranes. Yes, we do have lattice attachments, and we do have a guying arrangement, which we refer to as superlift on these cranes, but they don't have 400 tonnes sitting on a superlift tray 20, 30 metres out the back either. So it's pretty impressive what they can achieve. I want to give some important context here though, with regards to the cranes that I've compared it to. These types of cranes, like these big LRs pictured, as I guess Hansi pointed out, were not designed specifically for lifting tall hub height wind turbines. If we look at a scenario like this, these cranes are absolutely going to smash these all-terrains on chart. Okay, short, heavy loads at low heights, this is where these cranes excel. The other point is that there's not yet widespread demand exceeding the capabilities of the LG 1800, yet even the LG 1750 in Australia right now. Now, there are of course some downfalls of these all-terrains, and that's where I'm going to go now as well. And one of them, of course, is what wind speed can they lift in. Now, if we look a lot of our lattice boom cranes, you see even there the 1800 getting up around over 13 metres a second is a chart wind speed. If we go down a bit, the current the Sany 1,000 tonne track mount, it's getting around 10 metres a second. These all-terrains, so 2 in particular, the Zoomline and the Sany are rated at 8 metres per second as chart wind speed, and the XCMG is rated at 11 metres per second, which is quite an impressive increase, and I might quiz you on that on the panel a bit later, Stephen. But these 8 metres a second especially are a little bit concerning when it comes to productivity. Okay, when it comes to being able to get that window to achieve that required lift on a wind farm, and when that's our starting point, and we're then derating that wind speed based on surface area to load, we could be coming down quite low. So I guess once capacity is proven, a lot of the questions that OEMs are then asking is about relocation time, axle loads, boom laydown requirements, boom support pads, assist crane pads. All of these things start to come into play and the questions get asked. If we look at the current benchmark and go, for example, an LG 1750, if we go on full kit SX3, okay, rough numbers here, we could give or take a few hours, but at 20 tonne per axle, we're getting up around the 40-hour mark, right, for a full kit. Take the upper off, get down to 12 tonne per axle, right, you're adding at least 6 to 8 hours to do that. So we need a boom laydown corridor of 170 metres plus to deal with this, okay? And that's I guess, raising the boom of an LG at the moment, seeing the space it takes up. So there's of course potential advantages with these all-terrains that we don't need all the civil requirements of these big lattice boom cranes. But I guess it's not all rainbows and butterflies. It's, there's still quite a few challenges that need to be overcome, and they present their own challenges. If we're to move these cranes with the boom in, and if we want to even keep the outriggers in and the super lift on, we're getting up around or close to that 40 tonne per axle mark, okay? Call it 35 to 40. And we step down from there, of course. We can take super lift off, outriggers off, boom sections out, full boom out. So we can get it to the axle load that the wind farm is designed to, but then it comes down to efficiency. It comes down to what is it worth pulling these components off and the extra time to move them and all of those types of things. And then what overall time do we achieve? Quick clip here online, just showing the absolute size of these machines. It's the XMG 4000 tonner there. 11 axle machine. Overall width there, it's about 700 mil wider than an LG, for example, and 11 axles as well. So when we're talking about civils, road width, corner radius, all of these things are going to have to grow to cater for these machines. So the likely scenario, it's likely that you're pulling out at least sections of boom, but more than likely probably the whole boom would be expected. And of course, we can pull out those extra components. And the question is, what is going to be the overall time, the overall duration to get it set up? The benefits that we should gain with regards to boom laydown, okay? You know, right now, that's an LG boom laying downhill. We need all this space for assist pads, boom supports. These cranes, we still have to add lattice boom on, up to 120 metres, okay? And that's definitely not 120 metres. There's some benefits. They're lighter sections, okay? They can cantilever it a lot further. And you know, slew at any angle. We don't have a super lift tray constraining us to the angle. But we still need assist cranes as well. We still got to place those sections. We still have to have the space to do so. So I guess with that in mind, you know, we know that the trends are clear. Turbines are getting taller, components are getting larger, we're getting tighter margins. The demand for these cranes, I don't believe exists today. But there will come a time when the demand will exist. And it's a question of who will be ready and what options will be available to the market when the time comes. Thank you very much.